Hello, this short video is going to be covering the answers on the Unit 1 practice quest that we'll be taking here in class. So, first of all, this first problem is just talking about line of best fit and some general concepts there. There are 4 lines here to choose from. I'll kind of tell you right now, D is the correct answer. What you can notice about D that makes it look like a good line of best fit is it kind of goes right through the middle of all the points. You know, it maybe touches some of them, others it doesn't touch, but it's just a general expression of the trend of the data. If you look at the other 2 that are kind of similar to that, C and B, they both have these clusters of points above and below the line, all right? Where that's showing that, like, if there's large clusters of points above or below the line, that means that the line is probably not oriented exactly correctly. And that's even more pronounced in B. We've got this cluster, and actually this one here even, that's below the line, and this cluster that's above the line, and you can see when you do that that it's really not going through the center at all. And so C and B are bad for those reasons. If you look at A, the reason A is bad is just simply just connecting the dots there, and so that's not what we do when we do a line of best fit. So that is why A is wrong. Down here, looking at the problems on the bottom, they're all relating to this graph here. What it says here is there's a driver, and she's trying to figure out how far her car can go dependent on how much gas is left in the tank. And so basically what happens is she looks at her gas tank and sees how much gas is in there, and then she maybe uses that trip meter to see how far she can go before she reaches empty. And based on that, you know, she collects some data here based on how much gas is in her tank and how far she goes before running out of gas. So looking at this, the first thing here, it asks us to calculate the slope based on 2 points that I just give you here. This is just doing a simple change in y over change in x. All right? Which some of you like to say y2 minus y1 over x2 minus x1. That's fine. All right, so here, the y variables, that's 268 minus 106. All right, over 10 minus 4. This gives you 162 over 6. All right, which if you calculate should give you 27. All right, so that is A. For question 3 here, it says, what are the correct units on your slope? So remember again, we're doing y over x, right? So what we're going to do for a slope is say y units over x units. All right, so we have to look back at our graph and see what the units are. On the y-axis, we have total distance traveled, which is in miles. On the x-axis, we have initial volume of the gas tank, which is in gallons. The miles and the gallons are the units here. So the y units are miles, x units are gallons. Y over x ends up giving you miles over gallons, or miles per gallon. All right. If we look at all the different options here that's not on the list, okay, so the answer is E, none of these. Question number 4 is probably the most complicated question on here. It says, which is the best interpretation of slope? So looking at this, it says, I'll just go through in each option and tell you what I like about it or what I don't like about it. A, it says, the distance traveled when there's 1 gallon of gas in the tank. Okay, A sort of sounds like it might be nice, but what this is a description of a point. It's the distance traveled when there's 1 gallon of gas in the tank. All right, you could figure out what this is. You could go back and look at that graph and find 1 gallon of gas in the tank. All right, and you trace it up. It's like right here. All right, and if you extend this line, you know, you could see, all right, that's how far you travel. You know, it looks like it's in the 27 to 25 range, you know, somewhere in that range. All right, when there's 1 gallon of gas in the tank, how far it would travel. All right, but that's not talking about a slope. That's talking about an individual point. How far total distance traveled when there's 1 gallon of gas in the tank. So that's why this one is bad, is because, you know, even though it's talking about maybe the impact of having a gallon of gas in your tank, it's not really clearly worded, and it looks like we're just talking about a point. So A is bad for that reason. B here says the additional distance traveled for each additional gallon of gas in the tank. Well, you have to remember we're talking about miles per gallon here. So additional distance traveled, that's miles, for each additional gallon of gas in the tank, that's gallons. All right, so B actually sounds like a pretty good answer here because it's saying how far you'll go for each additional gallon that you have in the tank, miles per gallon, okay? The amount of additional gas in your tank necessary to travel each additional mile. Okay, C is talking about gallons per mile, all right? So that's not your slope because it's got the units reversed there. And then D is the amount of gas in your tank needed to travel 1 mile. The problem with D is it's also a point like A, amount of gas needed to travel 1 mile. That's just describing an individual single point there. So the one that describes your slope and describes it best is the additional distance traveled for each additional gallon of gas in the tank. All right, 5. The vertical intercept on this graph is close to 0. What are the units on the intercept? Okay, vertical intercept, vertical axis. Remember that. So for the units, we look at the vertical axis. If you remember there, vertical axis was measured in miles because it was total distance traveled. All right, vertical axis measured in miles here. So total distance traveled is going to be, sorry, not total distance traveled. Miles is going to be the units there for a vertical intercept because if it's the vertical axis unit, it's the vertical intercept unit. So miles is B. Going based on these, which one of these equations is a good equation to summarize the data? We've got y equals 23x. That's bad for a couple reasons. One, 23 is not our slope. Another one, don't use y and x, all right? B here, y equals 0.04x, all right? Again, this is bad because the slope is bad and it's using y and x. C, v equals 0.07d, all right? This one is bad for 2 reasons as well. It uses non-y and x variables, but it has the volume and the distance traveled reversed in terms of what side of the equation they should be on. The distance traveled is on the y-axis, so it should take the place of the y. The volume of the tank is on the x-axis, so it should take the place of the x. Also, that slope is wrong. All right? This is correct. D equals 27v. All right, distance traveled is on the y-axis, so D is a good variable there to take the place of the y. 27 is the slope, v is the x-axis. There's no y-intercept, so these are all plus 0. All right, so D is the correct answer. All right, all of the rest of these are going to be conversion problems, so I'll go through them. First one, 350 meters to miles. These first two are the non-metric conversions. So 350 meters, we're going to miles. So you need to go from meters to miles. You hopefully remember from class there are 1609 meters in 1 mile. All right, so then we just take 350 and divide it by 1609. And you end up with, actually here I'll write that. Across the top we got 350. Across the bottom we got 1609. All right, so 350 over 1609, you get 0.22. All right, which is D. For question 8, it says convert 45 miles per hour to kilometers per hour. So this one has a compound unit of miles per hour in there and kilometers per hour, but the hour actually doesn't end up impacting anything because it's maintained in both parts. But this is how you'd write it out. 45 miles per hour, so hours goes on the bottom. All right. Then we just need to get that miles to cancel out and eventually get to kilometers. So the only thing that we really know to get to from miles if we're trying to get in the metric system is that 1 mile is equal to 1,609 meters. And then if you think about your metric prefixes, you can figure out that there are 1,000 meters in 1 mile. All right, and then if you go through and multiply those together, you get 72,400 over 1,000, all right, which ends up giving you 72.4. So in this case, the hours really didn't do anything. We were just canceling out miles here and canceling out meters here, and this should have been 1 kilometer up here. And so that's what we get, 72.4 kilometers per hour. .5 hectometers to decameters. So remember kilo, hecto, deca, base unit, deci, centi, milli. All right. King Henry died by drinking chocolate milk. So hectometers to decameters, that's just jumping over one spot here to the left. So take our decimal point, jump it over one spot to the left. We get 265 decameters, which is A. Using similar logic here, 1,200 meters to centimeters. Meters is the base unit. We jump it over to centi. That's 2 spots over to the right. So we're going to take our 1,200, take its decimal point there, jump it over 2 spots, 2 spots to the right. All right, and we end up with 120,000. You can see there 120,000 is not on the list of answers, so it is E, none of these. Okay, so that is that. I know this was a pretty quick video, just a general idea on all of these. If you have any questions about any of these, make sure that you touch base with me before you take this test. Or I guess quest, because it's a short little test. All right.